Hello everyone, thank you for being here, and I hope that you still have some energy for yet another talk at the end of the day. My name is Obeida, and I work as Houdini Pipeline Supervisor at TAT Studio, and focusing on Houdini workflows for animation, films, and series. And today I will be showing you how we built what we call the AutoBake system, which is our own automated process for Groom animation in feature film. So let's take a look at what we do at TAT Studio. It's a French studio working on animation, films, and series, located in a beautiful city called Toulouse, in the south of France. And we work on our own IPs, producing both films and series. And we are about 200 to 300 people, from writers, directors, 2D and 3D artists, to technical directors, software developers, and production coordinators. We all work together in the same studio at the same location. And we have a hybrid pipeline. We have two pipelines, one for film and the other for series. The film pipeline is based on Maya, Houdini, 3ds Max, and New. And the series pipeline is based on Maya, Houdini, and Unreal Engine. And the average duration of a production at our studio is like 3 years. And at the moment, we're working on 2 to 3 productions for the upcoming years. And here we can find our recent productions that we have released. And our most famous IP is the Jungle Punch. Also, in addition to our own IPs, we exceptionally accepted a production for Netflix, which is Asterix: The Big Fight, which was released on Netflix this year in April. Also this year, we released Pets on a Train, our recent animation film. And we are working on a couple of productions for the upcoming years. And how do we use Houdini? We use it for everything related to effect simulation. We use it for grooming, for character effects, including cloth, hair, fur, and also feathers. We also use Houdini engine through 3ds Max to produce procedural geometry. And we are also planning and actively working on our future pipeline to switch to use the Solaris like everyone else. Now, let's keep focusing on the Groom animation pipeline and why it should be challenging. It should be easy, right? Well, no, not that easy, because it wouldn't be fun to work on it. First thing to know is that we are working in a multi-DCCing pipeline. We have Maya for rigging, layout, animation. Also, we have Houdini for everything, Groom, effects, and CFX. We still have 3ds Max and V-Ray for lighting and rendering. So how do we change all this data between DCCs? We use USD to send the animation data from Maya to Houdini. And we send everything from Houdini to 3ds Max using Alembic and Houdini. So I can let you imagine how the data traffic is in the studio and how the storage and network systems are just crying together in front of all this 3D data. So one of the challenges in the Groom animation is to optimize the cache size when we are sending it to rendering. Also, since we are working on everything on our own, we have a lot of characters, a lot of shots. Like in a single film, we could find about 80 characters across more than 1,000 shots, like 1,400 in average. We can find hair and fur on both animals and humans. Also, in the future, we are releasing a film with a lot of feathers. And sometimes we could find the fur on props. But our main concern is the characters and how to animate them and how to make the groom follow the animation. Now, a single production is about three years of duration. starting by R&D tests, both technical and artistic. And there's also pre-production and production phases for both assets and shots. And we can notice that regarding the Groom and CFX departments, they have each one less than a year of presence in a production. And during the production of Groom, we have the pre-production of character effects, where the lead or supervisor would be preparing the simulation templates for hero characters. And we have only 3 to 4 months of active production on shots. So we cannot simulate all the shots of the film in CFX. We can only simulate 200, 300, or maybe 400 shots of a single production in CFX. So we have to do something to animate all the rest of the characters. We need to make the Groom move with the animation. Now, let's take a look at how this AutoBake system was built. It's basically just a command line job using Python, which runs a script called runBake. It only takes 2 arguments, the shot name and the asset name. And this is what we have to send to the render farm for every single character on every single shot. Now, every night we have a published script that runs on every shot of the production, and it checks if the animation is published, and if it has characters with Groom, then it will send 1 job per character for every single shot. For example, 2 weeks ago, we had to send like 300 shots in production. We had to recompute all the Groom, so we generated around 1,000 jobs on the farm that calculated during 2 days. And of course, there's some situation where we do not want to release all the characters of a given shot. So we developed a separate interface outside of DCTs to send command line jobs by selecting the asset and the shot. And the runBake script, it basically works in a procedural way. It loads a heap file called the AutoBake heap. Then it sets up the scene with frame range and asset and shot information. Then it executes all the graphs in the heap file using a top network. So it's a single heap file to rule all the characters. So it's a procedural and modular template-based node graphs. On the top, you can find all the different deformation systems and the top network, which is used to manage the execution. Now, our main focus today is on the bake fur template, which is built in subs to deform hair and fur on a given animation. Of course, we have a controller AGA in the scene to manage all the file I/O, all the file passes, and to import all the related files to both asset and shot, like the mesh and the fur rest position and the animation file. And the bake fur system is built in a way to make it modular, and it treats all the different situations of hair and fur on characters. It is composed of a first block. The first block is about importing the data from the mesh, the fur, and the animation. Also to set up the groups and attributes of the fur. And then we have the deformation blocks with the different situations of every character. And also there's a JSON data imported as a dictionary attribute to manage exceptions in the graph for every character. We could also find some post-deformation corrections, like fixing the collisions with the fur, between fur, skin, and props. And of course, all of the subgraphs are executed using top networks to run all the wrap nodes in the heap file. Now let's take a look at the Groom deformation setup itself. The first block, of course, is about importing the rest position for both mesh and fur and animation file. This is how it looks like. We have 3 parts of mesh for the character. There's the white mesh is called the skin, which is the mesh under the Groom. It was used to scatter all the Groom curves. In violet, we have the proxy, which is a mesh it works like a bounding geometry around the Groom. It helps to make the Groom follow a given silhouette, which was posed by the animators. And we have some additional meshes like imported to manage collisions. And the fur itself is imported in rest position. And we set up some attributes such as the part attribute and the hair type attribute. These are describing the different hair generate nodes that serve to generate the fur. And they are all collapsed into different smaller parts, which is called the hair type. So we can imagine the hair type attribute like a piece attribute to be used in deformation later. Now let's talk about Groom deformers. The main deformation is done using a guide deform swap, using the by skin mode. It only helps to reorient all the curves around the surface. It's very efficient and very fast in this mode, and it will basically just take the Groom curves, attach them to a surface, and reorient them based on the surface term. But it does have some limitations, like it doesn't manage collisions between fur and the skin. So if we have some fur that is groomed in a way tangent to the surface, we will quickly have some intersection between fur curves and the geometry. So we can just use it to reorient curves around the surface. This is the example that we will be using as the middle. We could use the point deform swap, which is very efficient to make points follow the deformation of a given mesh. So we will make use of the proxy geometry, which is a bounding geometry around the curve, and make it follow the deformation. But also it has its own limitations as well. It's not designed to work with fur, so it could displace the fur from its own position. And it could stretch the curves, which is not what we would like to have always. But one of the advantages is that we could use a mask to decide on which location we want the point deform system. Now, what if we mix these two deformations? We can use the input from guide deform swap and the point deform swap, and using a procedural mask along the curves, and also inside the bounding geometry, we could make use of both of them. And then to correct the stretching of the point deformation, we can use a guide process swap to restore the initial length. Now, this is the result that we could obtain. At the root of the curves, we have the correct orientation based on the guide deform swap, and on the tips, we have a deformation driven by the proxy geometry. And we also restore the initial curve length. Now, what if we just mix them together? So we developed an HDA called guide deformed by proxy, or just guide deformed by skin and proxy. So we have both the skin and proxy geometry to drive the curve, but also by using all the masking and length restoration. And this is what we could obtain on a production asset. So here on the sideboards, we have the deformation driven by the proxy geometry, and on most of the body, it's driven by the guide deformed saw. One of the challenges also with this kind of deformation, because we do not do any simulation in this setup, so we do not manage any collisions, so we have to care about it. So here we have Rex, which has some props on it, and it has a fluffy fur, and it doesn't act very well with the props. So we have to manage all the intersections. So there is 3 parts of intersections that we have to manage. The intersection between the skin and the props, the intersection between the fur and the skin, and the intersection between fur and the props. So first of all, to deal with the intersection between props and the skin, we could use the VDB of both the skin and the props. And when they are intersecting together, we could just shrink the skin inside itself, inside its own VDB. And we can provide, we can put this inside a solver just to make it smooth along the time. And now to deal with the intersection between fur and skin, we could just use the guide collide VDB, which is a native node inside of Houdini. It just works in this situation. It allows to avoid that the curve, whenever the fur curves go inside the skin, it will just push it to the outside. And then to deal with the intersection between the fur and the props, we have to detect all the intersecting points. So we could use a group by bounding geometry or a masking by a bounding geometry. They both work. And the idea here is just to take the intersecting points and to shrink them to the first point, which is outside the props, or to raise them on the skin, so they will be hidden under the props. Another thing that we could do with Groom is to scatter some elements on the Groom. So here we've got some wood pieces on Falcon, and we could just take the fur curves and scatter some points on them and instance some points on this point, and to make them follow the Groom animation. So it's a process post fur deformation. We could just use the attribute interpolate node to make the points attached to the curves. And we can just remap the meshes on the points. Another challenge on the Groom animation is that we have a lot of Alembic data to send to this 3ds Max. And if we do not care about how much curves and points we have in the Groom, we could quickly saturate all the data traffic, all the storage system. So we could make use of the adaptive prosop, which is maybe not a very famous node, but it's very efficient to take a set of curves. It will delete a certain amount of them based on their visibility inside of the camera, and it will compensate the curve width based on the number of curves that was deleted. But of course, if we use this node as it is, it will not be convenient for us because it will change the curve count and the point count at every frame. So we have to find a solution to have a fixed curve count. But it's very efficient to delete points and curves. So in this example, it has deleted like 200,000 of curves and about 2 million of points, which is a big reduction in the geometry count. Now, how to make it work in a production situation? On the right, on the bottom, we have a camera minimal frame solver, which uses the adaptive probe to determine which is the frame where the camera is close enough to the groom and where it has kept the most of the curves, and we will select this frame to do the optimization on the rest groom on this camera. So at the output of this system, we do the test with a low resolution fur using the same skin animation. At the output, we have only a time shifted, a freeze position of the optimal position of the fur relative to the camera. And now we can just do a match size between the initial fur with the lower resolution fur and apply the adaptive probe in this optimal position with the freeze camera. So in a result, in a production asset, like if we take 10 frames of animation, without doing this optimization, we are like 570 megabytes. And if we do the optimization with some cameras that are progressively going far away, we can quickly go to 500 megabytes and 300, 200, like 170 megabytes. On 10 frames, this is only on 10 frames, so I let you just imagine how the impact on 100 frames. And let's take a look on some advanced concepts in Houdini. We have a system, template-based system, using the controller AGA. We can save node graphs as subnets inside of geometry or object level subnet, save them inside a heap file, and we can just merge the given node. And this is how we developed our template base, our templates in the pipeline. And also we could manage some exceptions between the different assets and shots. So we have a single sub setup to deform the fur and the hair, and we need to make it work with all the situation, with all the characters. So there's a possible way by using a JSON file to store all the different groups and exceptions and situations, and load this JSON file as a dictionary attribute. And we can make use of it inside attribute triangles to manage all the exceptions, to assign different groups based on the selection rules. This idea helps to reduce the amount of patches that we need to import on the heap file. So if we encounter a given character that doesn't need the deformation by proxy, we could just delete the proxy deformation in the JSON file, and we do not have to update the heap file on the JSON file, and we do not have to update the heap. And we can also, if we do not want to extract the JSON data as an attribute, we can just extract it as a string parameter and link it later to other nodes, like the blast node, just to make it make use of the groups. And this is all about the deformation setup, and some last words about it. For our future work, we are looking actively on working on a USD pipeline. So how would it work inside a USD pipeline? We could just use the AutoBake system to deform the guides and take the deformed guides into the hair procedural inside of Houdini and make use AutoBake, all the procedural in an indirect way. And shout out to all the people who were involved in developing the system, from the Houdini technical team to the software developers, and of course the character effects team who helped in debugging and investigating all the different situations, and all the CFX artists for their active feedback. And thank you for listening.
All right, time for questions.
Thanks, that was a great talk. Have a couple of questions. First one, so you didn't use guides at all in this, right? Like you were only ever working on the renderable curves for your deformation and stuff.
Yeah, we only work on the deformation.
Okay.
Yeah.
And was that like, were those being read in as caches into the AutoBake Houdini file? Like it wasn't like a live air gen or anything like that?
Yeah, the first prototype we did was using the hair generate nodes. We tried to import them and to deformat the guide, but we quickly encountered an issue where it was flicking from frame to another. So we just generated the Groom at rest position, imported the rest mesh, the rest Groom, and did the deformation later.
And then speaking of flickering, I was curious for your setup where you were fixing penetrations of props. How did you resolve the issue? If like there were hairs that were in props on certain frames but not on other frames, that it
yes,
going everywhere.
Yeah, it did produce some flickering at some situations. The first one is when the curve just can't find itself between the props and the skin. One of the things that helps to reduce this is to just push the skin inside itself, like aggressively. And another solution is to apply a solver on the detected mask, so it will just be smoother over the time.
And then you hinted that there were some shots where you did have simulations. So was that using a very different pipeline to this then? Or if there was character that actually had a simulation?
Yes. Yeah, the hero characters, the simulation pipeline is a different scene. We can just import the result of the AutoBake. So the character effects artists do not have to simulate the whole Groom. They will just select the parts that they want to simulate, and they will apply a guide simulation and then post deformation on the fur.
Cool, thanks.
Okay.
Thank you. Thank you for the presentation. It was really interesting. I'm curious about that JSON file, if you don't mind me asking 2 questions about that. You mentioned you remove entries when you no longer need some. How would you add features? Like say you detect a specific character needs a specific edge case. Obviously that wouldn't be part of the JSON file or the setup. Do you create a bespoke setup for them? Or do you?
Yeah, in this situation, we are in the obligation to add a new node block in the heap file.
And that heap file is used up for every character, and they don't run any request.
Yes, and yeah, it's like adding a new key in the JSON file by just selecting this given character, and the switching nodes, the node flow will make it in a way that only this character will go in this node block.
So you have one master set that runs everything, and each character chooses what it runs.
Yes, that's it.
Yes. and that JSON file is just manually edited when needed.
The JSON file is basically just listing the characters in which deformation mode they should be processed. Also, it is listing the groups of geometry meshes.
So, last note, just on your plans, I think that's the correct way to go. It's what we do, and it works really well. It's please.
Any other questions?
Sorry. I'm kind of curious why you decided to go with one master hip file instead of one per character.
Yes, we used to build a separate hip file for each character, but when we encounter a given problem, a generalized problem, it will be really painful just to update all the different hip files. So a single solution was much easier to maintain, especially when we are like 1 or 2 technical directors. Like, it's much easier to maintain.
All right. Anyone else? Okay. So all of this you use when you don't actually simulate the fur or anything, but when you do, which I assume you do for like some shots, how much of this do you actually use for that as well? Like, how much of this is shared between, oh, this is just a fake kind of job, or this is like a full-blown same kind of job?
Yeah, but by default, all the shots have the AutoBake output, and only the simulated shots will have a mix between the AutoBake and the simulated curves. But this is a choice done by the character face artist. It is depending on each character how the simulation setup was built, and in many cases, like we have some characters with a fluffy neck, but with a body that has a very short curve. So the simulation artist would just simulate the neck.
Yeah, so you can split between like simulating and not simulating, even though it's the same asset type.
Yes, it's the same asset. Actually, it's a starting base for CFX artists to attribute to manage attributes and groups in their firm.
Cool. And Hank, this guy had a question. Somebody getting in mic.
Yes.
Great.
So it sounds like the system works great, the automation works great in isolation. What if your characters are interacting with each other? Does that automatically mean you'll have to go in and manually adjust their collision volumes and so forth?
Yeah, the system is designed to make each character in its own world. It will not interact with other characters, with other assets. In this case, we have to make some simulation. So this kind of shots will be basically treated by CFX artists.
Was that a consideration when you decided to combine all of the assets into one file?
No, because the simulation pipeline is also designed in a way that makes every character in its own world. So we have to iterate each character in a separate way. So we would start the simulation for character A. Once it's done, we will do the character B and make the interaction in this way.
Okay, thank you.
Which Houdini are you working on right now? And are you thinking of simplifying the process in the future?
Okay, the first question is about the...
Which Houdini are you working on right now? Are you on 20.5 or are you on...
No, we started the system with Houdini 18.5. We upgraded it to 19.0, and today we are using 20.0. We did not use yet 20.5 or 21 in production. We are using them for R&D purposes only.
So are you planning on simplifying the process later on, like maybe using guides instead?
A part of this, the deformation part of this process is used to deform the guides in the simulation process. So this system will not be simplified that much in the future. It will be kept itself to deform the fur, and there will be another deformation template. Like this template is called the bake fur. We would have the bake guides just to simulate, just to animate the guides. But it will be basically the same system, the same rules.
Thank you.
Welcome.
Do we have any more questions?
Hey, great talk. Thank you very much for sharing that.
Thank you.